Hello everyone. In the part 1 of the volumetric analysis, I have discussed how to prepare standard solution of succinic acid, how to calculate the required weight of succinic acid, how it should be dissolved in measuring flask, what are the very important points to fill the solution into the flask, how to use weighing scale. So now in this part 2 of volumetric analysis, we will discuss the first exercise between zero point 0.1 normal succinic acid standard solution and unknown solution of NaOH. So let us read the aim. Determine normality gram per liter and molarity of unknown NaOH solution by using prepared zero point 0.1 normal standard solution of succinic acid. There are many types of the titrations. This particular titration is called acid base titration as it is between succinic acid and sodium hydroxide. So already I have discussed this preparation of standard solution. So let me advise you, if you directly watching part 2, so better you must watch first the part 1. Now this factor 1000 ml 1 normal succinic acid, if we want to prepare, this is a printing mistake in the book. It should be actually 59 gram succinic acid. This is a printing mistake. So we want to prepare actually 0.1 normal succinic acid. So we will again write 1000 ml 0.1 normal succinic acid equal to 5.9 gram succinic acid is required. But we want to prepare only 100 ml. So 100 ml 0.1 normal succinic acid required 0.590 gram succinic acid. How to weigh the substance on analytical balance or digital scale, that we have already discussed in the part 1. So accordingly, weigh the 0.590 gram succinic acid, dissolve it in a distilled water in beaker, transfer the content into the measuring flask and fill the flask up to the mark so that you can prepare that solution. So let us read the procedure. Weigh accurately 0.590 gram succinic acid powder, transfer it in a beaker, dissolve in a distilled water. Now transfer the mass into 100 ml measuring flask, dilute this solution up to the mark. All these things I have discussed by adding distilled water. Now friends, in the acid base titration, normally this is the particular titration is between succinic acid and NaOH. Succinic acid is considered as a weak acid, and NaOH is a strong base. So this is the titration between strong base and weak acid. So whichever is a strong, it should be filled into the burette. So here we will fill the NaOH into the burette. We will pipette out 10 ml standard solution of succinic acid into conical flask. In this picture, conical flask is shown. This is the it is a picture, so in which 10 ml succinic acid is taken with the pipette. We will add 2-3 drops of phenolphthalein indicator. Phenolphthalein indicator is colorless, remain colorless in an acidic medium and turn pink into the basic medium. So at the end point, our color change would be colorless to light pink. Now titrate this solution with the NaOH filled into the burette. First, keep adding 1 ml. When the color of the solution becomes red, note down the pilot reading. Friends, let me tell you, many teachers, they don't teach how to report pilot readings, but actually it is important because in titration, if we measure the pilot reading, then we can know the range of our reading. So let us take one example. Suppose in this experiment I have taken example of I have assumed that reading is a 10.7 or 10.8 ml. So whenever you are keep adding 1 ml, 1 ml, 2nd ml, 3rd ml, 4th ml, whenever we add 10 ml, we will get slightly color, but color will not persistent. And since reading is a 10.7, so when we add 11th ml NaOH, you will get the final color. So our pilot reading is called 11 ml, and it is indicating that our reading is somewhere between the 10 to 11 ml. So ultimately pilot reading is nothing but the rough range of our reading. Now, whenever you start taking the second reading, then up to 10 ml, you can add NaOH quickly from the burette. And once you reach at 10 ml, then after slowly, gradually dropwise, you should add NaOH till you get the end point. At the end point, color change would be this way, light pink. Here in this picture also it is shown that from burette we are keep adding NaOH. This is succinic acid, but whenever it end point gain, we will get the this kind of light pink color. Observations: in burette we are filling NaOH, with the pipette we are taking succinic acid. Indicator is phenolphthalein, color change is colorless to light pink. Equation: 1 mole of succinic acid, but it is a dibasic acid, so 2 moles of NaOH is required. Both these hydrogens, they displaced by sodium, so we are getting sodium salt of succinic acid, that is called sodium succinate, plus 2 moles of water. So thus it is a reaction between acid base and formation of salt and water, neutralization. Observation: here we will report pilot reading. We should report, or we should measure at least 3 readings. If you get the first 2 readings exactly same, then you can omit the third one, but if there is a change between the first 2, then you should go for the third one. And then we will write here the constant reading. And calculation, we are always calculating normality, gram per liter, and molarity of the solution which is unknown, because succinic acid is known in this case. So here we will calculate for the NaOH. Now let me show you how to calculate. So it is the same table. Suppose our first reading is a 10.7, so pilot reading is 11. Second and third reading are 10.8. Students should not, to write the constant reading, students should not take the average of these 3 readings. Instead, we can see that second and third readings are the same, so we should take that reading as a constant. Reason is that if you take the average of the 3 readings, then maybe you will get the average like 10.76 or something. Now burette, the burettes which we are using in a laboratory, it can measure either 10.7 or it can measure 10.8, but in between it cannot measure 10.71 or 78 something. So better, instead of taking average, you should go for the at least 2 readings which are very near. Now from the 10.8 ml NaOH, we can say that 10.8 ml NaOH is used to titrate 10 ml standard solution, zero point 0.1 normal standard solution of succinic acid. Now let us calculate normality. Formula is N1V1 equal to N2V2. N1V1 is for acid. Now succinic acid normality is 0.1. V1 we have taken it 10 ml. N2 is of the base NaOH we want to calculate, and V2 is this 10.8. So we want to calculate N2. So formula is N2 equal to N1V1 upon V2. So after placing the values, we will get the normality 0.093. And always remember that whenever you report normality, you must write capital N at the end. Now second calculation is gram per liter. Formula is normality multiply equivalent weight of. Now here many students make the mistake. Here we are calculating about NaOH. So you should use equivalent weight of the NaOH, not succinic acid. So 0.093 already we have calculated normality multiply 40 equivalent weight of NaOH. So we are getting answer 3.7 gram per liter. And molarity, last calculation. Its formula is normality into equivalent weight upon molecular weight. But in the case of NaOH, equivalent weight and molecular weight both are 40. So they will be cancelled, and that's why normality and molarity will be the same. Only thing, now we are reporting molarity, so we should write capital M, right? And conclusion table, it is the same one, this one. So solution is NaOH, molecular and equivalent weight are 40, and normality gram per liter and molarity that we have calculated, we have to fill up into the table. Now friends, there is a specific way to write this kind of experiment, volumetric, into the journal. So that is also important. So let me show you all these things which we have discussed. Certain parts must be written on the left page of the journal and remaining part is on the right page. So you must start writing such experiment on the facing pages. It is not like that, suppose your empty page is right side page. So you shouldn't start writing practical from the right page. No, you should start from the next page where you are getting both these pages empty. So see, aim, preparation of standard solution, procedure and conclusion. So let me show you in this aim, preparation of standard solution, procedure. Suppose you want to use, uh, suppose right side page is complete, then go on another right side page, turn on the page and so these three things and this conclusion. These are the things you should write on the right side page. On the left side page, observation, chemical reaction, observation table and calculation. So let me show you this observation first, underneath reaction, then under it observation table, and under it these calculations of normality, gram per liter and molarity. So always you should write in this manner.